Hi guys, I'm Francisco Smith from Man and Machine, and today we'll be having a look at Autodesk Nastran in CAD. This video is the first in a series that'll explore Nastran in detail, but today we'll just be having a quick look at the software and what it can do. If you've heard all the exciting news, Autodesk recently included Nastran and HSM into their product design collection, making it the product design and manufacturing collection. In my opinion, this is the best thing ever. To have full access to everything that you need to model, analyze, manufacture, and render your designs is just incredible and very, very exciting for people like me that like to make things. So before we begin, a little history. Nastran was an FEA program originally developed for NASA in the 60s by MSC. Nastran stands for NASA Structural Analysis, and it was intended to be a tool to let them optimize their designs in things like the space shuttle. Since then, it's been developed heavily, and it's changed a few hands. Today, it's owned by Autodesk, who have embedded it into their Inventor software as an add-in. Anyone that's interested in FEA knows of Nastran's really good reputation, so the fact that all this glorious power is now embedded into Inventor, it's like being wrapped in joy. So by this point, I've banged on and on about how good Nastran is, but what can it do exactly? Good question! Like all the other FEA programs out there, Nastran's all about setting up and running simulations. Basically, grabbing your designs and putting them into situations that you're interested in. Typically, you'd want to know what load your design can take, or how it will deflect under ordinary or extraordinary conditions. Perhaps you'd like to know when it'll start to vibrate, or whether it's as optimized as it could be. Nastran offers a whole bunch of analysis study types that can tell you exactly these things. Whether it's linear, non-linear, fatigue, there's an analysis type for it. Okay, so let's go through a list of the study types. If I'm going a bit fast, you can always pause the video and have a proper read of the descriptions. We'll start off with linear statics. Linear statics is the bread and butter of pretty much all structural FEA packages. It's the most common study type, and it's typically used to calculate linear stress, strain, and deflection in designs that are subject to small deflections and sub-yield stresses. Using the same setup, you can easily calculate thermal stress, pre-stress, and fatigue. It's a bit limited in the kind of problems that it can solve, but it's also the staple go-to because it's quick and easy to set up and very fast to compute. Next, we've got nonlinear statics. In my opinion, nonlinear statics alone is reason enough to be excited about Nastran. On top of being much more robust than linear statics, nonlinear can handle nonlinearity in material properties, changing loads and boundary conditions, large deflections, and plastic deformation. If it's a bit heavy computationally, it's because it's just so powerful. We will look into how to use it properly in episode 3 of this series. Next we got normal modes. Normal modes look at the frequencies of structures and their undamped natural mode shapes. Very easy to set up, very quick to compute. This analysis type will let you know what the natural frequency of your design is and if it'll be a problem. Next, we've got buckling. Structural buckling analysis can either be linear or nonlinear, and will reveal if your design is stable under compressive forces. It can compute both nonlinear and linear, and will output critical loads and their resulting mode shapes. Nastran also allows for all types of thermal analyses, including linear steady-state heat transfer and nonlinear transient heat transfer. By inputting the thermal boundary conditions and how the material responds with respect to changes in temperature, Nastran can calculate the thermal behavior of your design. Thermal stress analysis is what it sounds like. Nastran will compute how thermal loading induces stresses in your design. The best part about this is that the inputs can be taken directly from your previous heat transfer studies. Next is the absolutely awesome linear and nonlinear transient response. Here we can simulate constant or time-dependent loads to capture the nature of impulse loading on your design. In the same vein is the clever automated impact analysis and drop test, in which you can very quickly subject your design to a simulated drop on solid ground. Both of these are dynamic analyses and take the inertia of the material into account. Lastly, we have the excitation from random response or frequency response, where you can see how our designs respond to enforced harmonic excitation, time-dependent motion and loads, shock loading, and random excitation. It's your chance to give your design a good shakedown. So those are some of the study types. I'm sure that there are a few that I forgot to mention, but before I go, I'd like to discuss quickly the kinds of materials that Nastran can deal with. Firstly, we have the linear materials such as metals and alloys, which behave linearly and elastically. These are the most common in all FEA packages. But where Nastran really cuts the cheese is in handling nonlinear and hyperelastic materials. Materials that behave either non-linearly or plastically are incomputable by nonlinear packages, but Nastran can handle them just fine. metals, alloys, shape memory alloys, rubbers, plastics, soft tissues. If you can describe how the material behaves to Nastran, then it can incorporate that into its analyses. Lastly, and fantastically, Nastran can deal with composites. This is really fascinating, as typically analyses involving composites are considered difficult. Whether they're 2D laminates or some kind of 3D configuration, if you can describe how the composition and orientation of the composite material goes, Nastran can incorporate it into its analysis. Truly powerful stuff. Okay, unfortunately we've run out of time for this episode. Over the next dozen or so videos, we'll be exploring each of the study types that we mentioned earlier, and look at all the material types that Nastran can handle. As they come, we'll also discuss the changes that are made to the software by Autodesk. By the end of it all, you'll be a pro and ready to go with Autodesk Nastran in CAD. Okay, thanks for watching guys. Like and subscribe if you'd like to learn more, and stay tuned for the rest of the series. Happy engineering!